Hi, I'm Mr. Oh Ming Yeo. Okay, I'm going to discuss how friction plays a part in Newton's second law. Okay, let us consider the previous questions, with the exception that now I'm going to add in a friction of 25 Newton between the mass and the ground. Okay, so in this case, how do we find the resultant force? Okay, before we do that, right, let me introduce a new term called the applied force. Applied force is actually the combinations of all the forces that are applied on the 5 kg mass. So in this case, it will be the 20 Newton, 30 Newton, and the 10 Newton. Okay, so any forces that are in the same direction, we add it together, and then any forces like the 10 Newton is in the opposite direction, we have to subtract it. So applied force in this case will be 20 plus 30 minus 10. So this will give us 40 Newton. Okay, next we can go on to find the resultant force. Resultant force is basically the combination of the force applied and the friction. And since friction always opposes the applied force, resultant force in this case, it will be the applied force minus away the friction, which is denoted by a small letter f. And this will give us 40 minus 25, which is 15 Newton. Okay, with the resultant force, we can move on to find the acceleration, which is resultant force is equal to ma. So 15 is equal to 5 times a, and a is actually equal to 15 over 5, which is 3 meter per second squared. Okay, with this we can actually modify the formula. Resultant force is equal to ma to become applied force minus friction, because the resultant force is actually equal to applied force minus friction, and this will give us ma.